Alright, well, welcome to lesson 10.2 on areas of parallelograms and trapezoids. These are two of the types of quadrilaterals that we looked at in the last lesson. We're going to get a little bit more specific. Find the area. Remember, the area is the space inside the figure. So we're going to do a couple definitions here first and set up the formula. Now, what I've tried to draw here is a parallelogram. It's kind of hard to tell, but this is supposed to be parallel to this, and this is supposed to be parallel to this, here like such. However, my drawing's a little tough to read sometimes. But I have a parallelogram, and I'm going to talk about the base of a parallelogram. Now, as it turns out, you can use any side for the base. I typically use the side that's at the bottom of the drawing, only because I think of base and basement. But it's the length of any one of the four sides. So I'm going to call this part right here, for all intent and purpose, the base of the parallelogram. The height of a parallelogram is the perpendicular distance, and this is key, perpendicular distance between the side whose length is the base, and in this case, this guy, and the opposite side, which would be this side, the side that's parallel to it. So what I'm going to try to draw here, and I'll just put like a dotted, I'm not doing a very good job here, is the height. This is what I would call the height right here. This distance here, I'm going to put an H here, I'm going to put a B here for base and for height. Now, as it turns out, what we're going to do here is we're going to find the area of this. And I've already got the formula written down. Let me explain why. If I draw another perpendicular line segment here, and then take this piece and move it over to here. Not doing a very good job drawing this. What I would have then is a rectangle. And we know how to find the area of a rectangle. The area of a rectangle is length times width, or base times height. So that's exactly what's going on here. The area of this shape is just going to be base times height. Remember, the base can be any one of the sides, and the height's the perpendicular distance from the side who we've called the base to its opposite side. So I'm going to do a couple quick examples here. I'm going to find the area of a couple parallelograms. The first one's in a story problem form. The height of a parallelogram is 12 centimeters. The base is 2/3 the height. Well, then what I need to do is I need to find 2/3 of 12, which is 2/3 times 12, or 12 over 1. I do a little cross canceling, and that's 8. So the base is 8 centimeters, and the height is 12 centimeters. Well, look at my formula here. Area equals base times height. So my area is base, which we just said a second ago was 8 centimeters, times the height, which was given in the problem to be 12. Now I multiply 8 times 12, I get 96. Remember, areas in square units, we're multiplying centimeters times centimeters, so I can either write square centimeters, or I can use this abbreviation here for square centimeters, centimeters squared. And that would be the area in the problem there. This one, I have a diagram. I'm asked to find the area. Everything is right here. Look, with this drawing, you can tell that you have a base of 6 meters, a height of 5 meters. The area is base times height, which would be 30, and because it's meters times meters, square meters. Okay? Very simple formula to remember for parallelograms. Now, a little different with trapezoids. Now, with trapezoids, remember, those are quadrilaterals that have exactly one pair of parallel sides. Well, that pair of parallel sides, here and here, those are called the bases. I'm going to call this base 1 here. I'm going to call this base 2 here. Those are the bases. The bases of a trapezoid are the lengths of the parallel sides. The height of a trapezoid is the perpendicular distance between the sides whose lengths are the bases. So, perpendicular to both, this would be my height. And this gives me the information I need to find the area of this shape, the area of this type of quadrilateral. I'm going to show you that next. Okay, I put the drawing again of my trapezoid, and you may notice I have with dotted a congruent trapezoid attached to it. In fact, what I tried to draw was that this side would be over here, and this side would be over here. Now, because these are parallel and these are parallel, these two sides are parallel, and as it'll turn out, these two sides here are parallel. I have a parallelogram. To find the area of a parallelogram, it's base times height. Well, my base here is these two added together. So if I add B1 plus B2, If I add those together and multiply it times the height, I have the area of the parallelogram, which is double the area of the trapezoid. So to get 1, I'm going to multiply it by a half. And now you can bring it over to here and you can see my formula for finding the area of a trapezoid. It is 1/2 times the height times the sum of the bases, b1 plus b2. So I'm going to use that formula to work a problem out right here. Find the area of the trapezoid. Well, the area will equal 1/2 times the height, which is 8.5, don't let that decimal mess with you, times the sum of the bases, which are 4 and 9. So 4 plus 9. Now, by the way, these are the bases. I may have mentioned this before. These are the legs of the trapezoid. So I have to multiply 1/2 times 8.5 times 13. So it's time to grab a calculator. I'm going to multiply 0.5 times 8.5 times 13, and I get 55.25. Now, since these measurements were in meters and this is area, this is in square meters. Now, the next problem is a little different because in this problem about the trapezoid, I give you the area and we're looking for one of the missing measures. It says the bases of a trapezoid are 11 inches and 17 inches. The area is 56 square inches. Find the height. So I'll just draw a little picture here. Alright, I'm trying to find the height. That's h. I know that this is 11. I know that this is 17. Well, I'll plug in what I know into this formula, solve for what I don't know, which is the height. So the area is 56 equals 1/2 times the height, which I don't know, times the sum of the bases, which is 11 plus 17. Well, in the parentheses, I'll do that first. I have 1/2 times the height. If I add those together, I get 28. And I'm going to commute these and multiply a little commutative property, associative property. 1/2 of 28 is 14. I solve for h. I divide both sides by 14. And I get h is equal to 4. So this was in inches, so the height is 4 inches. So notice here, plugging into the formula, we've done this many times before, not just with this formula though, with other formulas, and you solve for the unknown. Now a couple of offshoots here. This one here we've got a banner, which is supposed to kind of look like all one piece here, made up of 2 congruent trapezoids, and they're asking you to find the area. Well, we have to assume then that this is a right angle here, and if that's indeed the case, that's my height of the top trapezoid, and that's my height of the bottom trapezoid. Since the trapezoids are congruent, all I'm going to do is find one and then double it. So the area would be 1/2 times the height, which is 2, times the sum of the bases, which are 6 and 8. So half of 2 is 1 times 14 is 14. Now that's just one of them, 14 squared. These are in feet, square feet. So I'm going to multiply now by 2, and I get 28 square feet. And that would be the area of the banner. Now this last example is a little bit like the one above it. I give you the area and I'm asking for a particular measurement, in this case, the base. So we go back to the formula, which was on the previous screen. Area equals base times height. This is simpler than this one. No fraction. I'm going to plug in the height, 14, and the area, 210. So I get 210 equals the base times 14. Divide both sides by 14. And 210 divided by 14, if I'm not mistaken, is 15. And this is in meters, not square meters. It's not an area. It's a length of a line segment. It's in linear measure. Area formulas are key. You're going to use them in Algebra 1. You're going to use them in geometry. So the more you practice this stuff now, the better off you're going to be. So as always, practice, practice, practice.